Good morning, everyone. Good morning, everyone. Welcome. Yeah. Mic testing. Mic testing. Mic testing. And from the phone, people did the song. Hello. Hello. Hello.
കേൾക്കുന്നുണ്ടോ?
हेलो चेकिंग। हेलो नीतू। Hello. Good morning, Prime Minister. Hello.
Yes, sir, it's audible.
Yeah. Okay. I was just checking. Hello. Hello. Again, checking the system. Good morning to all of you.
Hello. Hello,
Hello,
are we
Father.
all? Yes, yes, I can listen. Am I audible to you?
Yeah. Yes, Father. Yes, Father. Yes.
Okay, then, fine. Things are working perfectly all right.
But how about your video? Yeah. It's fine. Good.
Good morning, everyone. Welcome to the inauguration of our 6-day online FDP on advanced communication systems shaping next generation networks. I request everyone to please ensure you are connected online. We begin by seeking divine blessings. We can start with a silent prayer. I now invite Reverend Father Dr. Jose Kannambula, Academic Director, JEC, to deliver the welcome address.
Most respected Dr. S. Somanath, the chief guest of the day, Dr. P. Sojanlal, principal of Jyoti Engineering College, head of the Department of Electronics and Communications, Jyoti Engineering College, Dr. Josephine Nagar, coordinators of this FDP program online, faculty members, participants from various parts of the country, gentlemen, ladies and gentlemen, and my dear friends. Today, we have the inauguration of this 6-day online FTP on advanced communication systems shaping next generation networks. And this is an exercise making use of the advanced communication system through the internet. Till recently, we were all having FTPs offline. But after the main issues of previous years, we have started doing things online very profusely. Everywhere this is taking place. And much more strength has been introduced, added to this system. So we can sit in different corners of the world, chat together, sit together, converse together, communicate together. And this is the beauty of this wonderful system. So communication is getting developed, escalated to very good heights. And we are focusing on the advanced communication systems, shaping the next generation networks. And this is going to be a big reality. And we have got wonderful speakers for this online FTP. And as the chief guest of the day, on this inauguration day, we have got Dr. S. Somnath, the former Secretary of Department of Space and the Chairman of ISRO. He is a distinguished visiting professor of Indian Institute of Science, Bangalore. He is a Chancellor, Chanakya University, Bangalore, advisor of the space technology of the AP government, and so on and so forth. Dr. Somnath, sir, we are extremely proud of you as an Indian and also as a great man from Kerala. About Dr. Somnath, he had his education, primary education in his nearby places. His engineering he had from TKM College of Kollam in mechanical engineering, and he had his master's in space, aerospace from Indian Institute of Science, Bangalore, and PhD from IIT Madras. He joined BSSC in 1985 and was making strides one over the other. And finally, in 2022 January, he became the chairman of ISRO. And he retired in January 2025, 3 years tenure. And that was a landmarking exercise. And sir, we are really proud about it. During this tenure, the ISRO undertook the third Indian lunar exploration mission, Chandrayaan-3, which had landed near the South Pole region on 23rd August of 2023. And India is the first country to land successfully, making a soft landing near lunar South Pole. No other country so far could achieve that. And definitely we should give a good clap for his great achievement. And he is a friend of our principal, Dr. P. Sojanlal also. He is doing a great work. We are extremely grateful and extremely honored, sir, that you are here present to inaugurate this function and deliver a keynote address on your topic on inauguration and keynote. And apart from him, we have got good speakers. Dr. Unnikrishnan, Dr. Tracy Thomas, Dr. Jobin Francis, and so on. And all these people will be delivering great lectures on different topics. So on behalf of the whole Engineering College Jyoti, and on behalf of the entire group of people who are assembled to be the resource persons who are delivering lectures, and also the participants sitting across the country in different parts of the country, and on behalf of all the people, I accord a very, very warm welcome to you, Dr. S. Somnath. Also, Dr. P. Sojanlal, our principal, is sitting here. On behalf of the entire program, I accord a very warm welcome to Dr. P. Sojanlal, the principal. Now, on behalf of the entire group of people who are organizing this, we accord a very warm welcome to the head of the Department of Electronics and Communications, Dr. Jose Peter Artel, various faculty members, organizers, and all the people at the back of it in organizing this thing. I accord a very, very warm welcome to all the people and appreciate the hard work the Department of Electronics and Communication have put in materializing this great endeavor. Also, I accord a very warm welcome to the participants. Various faculty members sitting in different colleges in different parts of the country. We understand that people from outside Kerala also are participants in this one. So my general advice to the participants is that make use of this great opportunity about this advanced communication systems for the next generation. You can collect a good number of points and then you can network and let it be used for ourselves, for our personal growth in the science world, in the technical world, and also to contribute to our student community at large, so that finally India will be better in quality and in scientific temper. And this must be materialized through this online FDP. Let it happen. This is my wish and prayer, and asking everyone to join. I thank you all and I welcome all to this wonderful 6-day program FDP on these advanced communication systems shaping the next generation networks. Thank you all.
Thank you, Reverend Father, for those warm words of welcome. I request Dr. P. Sojalal, Principal, Jyoti Engineering College, to kindly deliver the presidential address.
Good morning to all of you. Respected Honorable Chief Guest Dr. S. Nasser, Reverend Father Dr. Jose Kannambura, all other dignitaries, and esteemed participants. Good morning to all of you. As Dr. Father has mentioned about the achievements about Dr. S. Somanath, sir, all the Indians, we know that, sir. We congratulate, appreciate your leadership, and also we are extremely thankful for joining us. So I don't elaborate much on this as we are waiting for his speech. So once again, welcome to all of you and thank you for joining today.
Thank you, Dr. Sojalal, sir, for your inspiring address. It is my greatest honor to invite to the dais a man whose name is forever etched to the stars. Dr. S. Somanath is one of India's most celebrated space scientists and engineer. As chairman of ISRO, he guided the historic Chandrayaan 3 mission to a successful soft landing near the lunar South Pole, making India the first nation on Earth to achieve this feat. Under his leadership, India also sent the Aditya L1 observatory to study the sun, demonstrated space docking through SpaceX, and opened India's doors to commercial space with the LV-M3 OneWeb satellite launches. A proud graduate of TKM College of Engineering, Kerala, Dr. S. Somanath went on to earn a gold medal master's degree in aerospace engineering from Indian Institute of Science and a doctorate from IIT Madras. His academic journey is a testament to excellence, from the classrooms of Kerala to the corridors of India's premier research institutions. Considering his major achievements, Dr. S. Somanath has been recognized with the highest national and international honors. He is a recipient of the IAF Hall of Fame Award, the National Aeronautics Prize, the Space Gold Medal, distinguished alumni awards from both Indian Institute of Science, Bangalore and IIT Madras, and the Karnataka Rajyotsava Award. He is a fellow of INAE, INSA and ASI, a member of the International Academy of Astronautics, and has served as Vice President of the International Astronautical Federation. He also holds numerous honorary doctorates from leading universities across India, a reflection of the immense respect and admiration he commands in the academic world. Today, He continues to shape India's future as distinguished visiting professor at Indian Institute of Science, Bangalore, Chancellor of Chanakya University, and advisor on space technology to the government of Andhra Pradesh, a dreamer who turned national ambitions into orbital realities. We are greatly honored and privileged to invite Dr. S. Somanath online as our esteemed chief guest of the Faculty Development Program on Advanced Communication Systems Shaping Next Generation Networks, organized by the Department of Electronics and Communication Engineering of Jyoti Engineering College, Cherudurthi. We warmly welcome his gracious online presence and inspiring address to our student faculty community. Welcome, sir.
Thank you so much. I hope I am audible there.
Yes, sir. Yes, sir.
Yes.
Yes,
Okay.
sir. Very-
Okay. Thank you so much once again. Thank you for the nice introduction and an opportunity to speak on this occasion of this faculty development program. And thank you specifically, Dr. Sojan Lal, principal of Jyoti Engineering College, as well as our Reverend Father, and also all the participants who are there, and also the speakers that are going to be there in the coming 6 days of program engagement with all of you. I believe this faculty development program is targeted with across the country. I believe that this interaction will be reaching to all of them. And the topic that you have selected is again something very relevant. One, of course, is you talk about two things. One, again, communication, and another is networks. I think these both are very, very relevant topics. Communication, of course, is a fundamental, and network is the infrastructure that is enabling us to do this communication activity. But then, of course, this is through various ways of networks that we are able to achieve. We talk about terrestrial network, we talk about space networks, and a fusion of many of these. I think this also in the domain of technology, in the evolving landscape of communication, there are new technologies emerging, and the one being high throughput communication, especially for all of you who are users of mobile and high data, 5G, 6G becomes very important component of this evolution. And correspondingly, the frequencies, the long distance, short distance communication networks, the Wi-Fi networks, the specifically addressing sensors and instruments, that type of networks which are very, very local. The one which is going to help us in terms of future ready data churning and including AI, the networks that are high throughput networks that will work in space. I think all of this will become very, very significant component of this all of this architecture. I think this is an exciting area, huge amount of research happening across the country at many places. But I think these topics will spread over many days to discuss, and every element of that requires to be discussed, especially topics which are related to the frequencies, the domains of bands that you are going to use, and technology associated with the devices in each of them. The formation of networks that will allow you high throughput as well as specific communication features, including building blocks, reflections, isolation, and many such issues which are going to be a part of it. But me being part of the space community, I think I thought that I will give a lecture specifically focusing on space infrastructure as far as these communication networks are concerned, and how it's going to evolve in the coming days. That's going to be my talk that is going to follow. So let's not go into further details, because experts in many domains will come to talk about it. I will limit my domain to only this. So with that, let me wish all the very best for the faculty development program and also the interaction that are going to happen. Thank you so much, and declare this whole program of the Jyoti Engineering College from the Electronics and Communication Engineering Department, who is spearheading this program. Wish all of them very best and declare this program inaugurated. Thank you.
Thank you, sir. So you can continue your presentation, and finally we'll go for the, you can show.
Okay. So let me Hope this is visible to you. Let me check.
Yeah, yes, sir, yes, sir.
Okay. I hope that my opening slide is visible.
Yes, sir, visible, sir, visible.
Okay.
It's clear. Please go ahead.
So now let me start telling what exactly are the India's communication infra and network. So of course, this talk can be very global, but then let me limit more and more to the Indian context. Today, if you look at our communication infrastructure and networks, we see that India is the largest digital communication ecosystem. We evolved recently in less than a decade into such a very powerful capability and substantial strength in this telecom communication infrastructure, especially the telecom access, digital public infrastructure, the UPA and many others, the fiber network expansion, which happened because of the private initiatives as well as government, creation of huge data centers, digital payment networks. I think all of this have come up in the recent times, which the benefit of which all of us are enjoying. But the challenge still remains because India is a very vast country, that its range and reach in rural broadband capacity is still limited because much of the broadband capacity is still in the urban areas. Then we import huge amount of equipments for that maybe 10 lakhs old towers which are there. Also we know that satellite backhaul and backup capacity in communication is not as great as we really need. So if you look at our telecommunication networks, we see India is now the world's second largest telecommunication market in terms of utilization of data. And we are one of the cheapest in terms of data usage. We have almost 1 billion internet users online from India. And the subscribers of broadband exceeds almost 970 million. It's such a huge number compared to many other parts because it is offered at very low cost. And mobile broadband is a major mode of communication. And we know that primarily Reliance, Jio, Bharati Airtel, Vodafone Idea, and BSNL occupy this market space. And we are also evolving the 5G networks. The rollout of the 5G is among the fastest. I think this is something really great. Once it has been announced, India is able to bring out very, very fast. And it is also spreading to many more districts now. Almost 100 million out of the 970 million users are already switched over to 5G capacity. And 400 million 5G subscribers are estimated to grow. And fixed wireless access is also emerging. Now, let me go to another topic. What drives the communication expansion in the whole sector? Because it is growing, and actually the social needs are what actually increases the demand for communication. And we see the primary reason being the Digital India initiatives. And out of this, there are 9 pillars, which says the broadband, the public internet, the information which is required to reach everyone, and early harvest program primarily looking at young students and children, universal access like phones to everyone, and IT jobs increasing primarily through the electronics deliveries services and other software services. And similarly, e-governance. I think you know that digital governance is becoming one of the important topics. Similarly, to support the manufacturing, especially for net zero support. So we know that after it is launched in 2015, Digital India Initiative has really become very prominent aspect. We'll go through the details later. Another important area is that slowly now India is stepping up its semiconductor manufacturing ecosystem, primarily looking at packaging and large-scale production that will support both communication infrastructure as well as mobility and many other consumer goods area. And we are having an aspiration to grab at least 10% of the electronics manufacturing market in the coming days. And also looking at some compound semiconductor as well as silicon fabs. So this is coming up very big way across the country, and there is a huge government support to help grow this. So this is going to be a fuel for this communication infrastructure development. Another is, that AI utilization, AI tools development is also fast tracking in India with the Bharat Gen large language model development happening. Also, the compute infrastructure targeted to around 10,000 GPUs to happen in India. And there are foundation model creation happening in specific sectors, including engineering sector, medical sector, agri sector, etc., etc. And there is an effort on safe and trusted AI tools development. So possibly India can become one of the important trendsetter where the language models, the diversity, the need to cover large amount of people and applications really be going to really create a huge communication demand for AI. Another area is electric mobility, where there is a large demand for electric cars and scooters, which demands more information to be gathered from these vehicles to the network for diagnosis, health, and statistics, as well as maintenance support, charging support, and many other intelligent activity that will happen in the background. So these vehicles are going to become more and more intelligent, communicating with the networks, and correspondingly, this is going to be one of the important component of the networks in the coming days. Currently, they are not, but they will become. Similarly, in the power electronics, batteries, charging infrastructure, identifying charging infrastructure, and many of this, the penetration of EVs will really increase the demand for communication. Agriculture is also going to increase the demand for communication, because we are also looking at modern tools for agriculture, especially the precision farming, personalized measurements, post-harvest support, bio verification, climate resilient crop varieties, sensors, IoT-based support, precision delivery of pesticides, etc. So all of this is going to be important, coupled with the drones. I think that we will see later. Medical and healthcare area also, there is going to be a huge demand, because there are many frontiers emerging, especially consulting through the doctors, collection of health data, looking at spread of diseases, pandemic preparations, distribution of medicines, and AI-based solutions, integration of Ayush and other modern healthcare platforms and data management. All of these are going to be network-driven as well as data-driven and communication-driven. Cyber physical system, I think all of you know that it is actually a connection between robotics, sensors, and algorithms. And here there are many things, including air mobility, drones, blockchain data, navigation, which are required to be autonomous. I think all of this requires infrastructure to be developed, yet to be identified and developed to support all of this. For example, if drones have to do people movement, then we need to create corridors, communication infrastructure, weather-related information, safety. All of this requires huge infrastructure to be created. So cyber physical system also will grow in the coming days, because robots are also going to grow. Yeah, autonomous machining and manufacturing facilities are going to grow. So all of this will have its own communication infra in the coming days. Cannot run on internet alone. I think we need dedicated networks. Drones also slowly entering into many areas, warfare. It has always been then delivery, medical, security, transportation, agriculture, etc. And they are going to take different shapes, and many of them requires piloting, management requires communication networks, not just the pilot alone, but it has to be connected to the larger scale networks. So essentially what we say is that satellite connectivity may be one of the area that game changer for this type of activities, where we will have to have satellites to well connected to internet, which is only emerging today, but it is slowly going to become bigger. And equally important is the data analysis that will come out of all of these networks, because business intelligence is based on data. And synthesizing data using AI, surveillance, and other analytics, which will finally get into the communication networks to support entire business processes. So now let us look at space and what India has done in the communication infrastructure. If you look at India's satellite communication capacity, it's not very large. There are only hardly 10 satellites which are currently with NSIL, and there are 3 of the high throughput satellites with NSIL, giving almost 25 GPS high throughput capacity, currently used by many of the cellular operators, backhaul services, VSAT services. And most of the DTH and other VSAT services are also handled by the transponders of the Indian satellite. But there are special satellites which are built for space, our security people, and also international cooperation. So this is the total array of satellites that are currently there in space for communication. If you look at its utilization, and it is spread across 48° east to almost 97.3° east, this is far large span of area which covers the Indian subcontinent and other adjacent nations. So 11 of them being owned. So totally we know that around 14 plus 4, 18 satellites are there, which gives you almost a good capacity. It's meeting all the DTS requirements, but coverage is still very small. And new satellites are currently being discussed, including companies from O3B, OneWeb, etc., and Starlink are all under discussions. So I think you can also note that our slots available for the satellites are not many, and many of the slots are filled with a large number of satellites co-located, which is also a challenge in terms of life and spectrum allocation and things like that, which I don't want to discuss at this moment. And many of the satellites are now becoming very commercial. Earlier, Government of India used to launch the satellites and provide services. Now it's no longer Government of India. These satellites are going to be built by private money, and one of them is already built and launched, and others are going to be launched soon for commercial applications. So many of the national services, including defense, paramilitary, railways, fisheries, and all will be taken from such privately owned satellites, which will be launched by possibly means ISRO or private activities. So this is another change that is happening. And these are strategic satellite users, and it will be only for them and won't be available to you. They are called GSAT, 7R, 7B. These numbers doesn't matter to you, but they are the one which will provide targeted communication services for our strategic users, including Navy and Air Force. But you look at the services distribution for this satellite, we see that there are still some foreign operators operating in this country. Some of them, many of them are domestic, but then foreign capacity is still significant. That means we lease this capacity from some of the foreign satellites and provide services to Indian operators. So who are these operators? Some of them are DTS services, some are teleport services, some are VSAT connectivity. You know, VSATs are the one which are used for ATMs and things like that. And private, government, and strategic users all hire this from government as well as from NSIL as well as from private. So this is the type of utility currently happening. And we can also see that the commercial and government uses, if you see, commercial is still very high percentage of use. You can note that so many channels are there, no? Thousands of channels in your television and internet that is available. It's all account of this type of data services that are available from satellites, meeting very entire coverage of the country as well as the high demand that are there in the urban areas. So we meet all that requirements through our satellites today. Now let us look at the new domains and the needs that are required in the communication infrastructure. The emerging needs in the satellite communication is high throughput. You know, high throughput means the data rates will be in Gbps. And another thing is that you need to have direct mobility. Today, to receive any signal from satellite, you can't directly receive on your mobile phone. You need a small dish and a Wi-Fi router. Then only you can actually access the data. But then how to directly receive without any hardware change in the mobile is one of the question. And another is flexibility to meet market demands through software-defined functions. Then, because the area is getting crowded in terms of frequency, so exploring the new bands like Q, V, W bands, and including optical bands, optical frequencies through optical communication networks, so that you are not cluttering the RF spectra. And then another area is called space-based quantum communication, where the security of the communication is achieved through quantum key distribution that will happen through space. So correspondingly, there is a set of satellites under development at various places, and many of the existing networks are also getting modified, reflecting these changes. So coming to the quantum key distribution, ISRO has been doing this effort, including an optical network creation. So this is under development, and soon there will be a launch of a satellite which will onboard some of these technologies as well as software-defined radio to demonstrate the on-demand as well as the software-defined function will allow you to switch frequencies. It will allow them to switch the beam shapes, the throughput at various places dynamically. So this is a really very good technology which will actually future-proof some of the satellites which will be launched in the coming days. Of course, there are in strategic area where there are many challenges and many demands, like such as early warning satellites. Instead of radars, why don't you use satellites to track the missiles? Similarly, look at space domain awareness to look at how other people are likely to interfere with our satellite operations and then protect them. jamming and proofing in such areas where there are communication infrastructure to be handled during exigencies. Similarly, communication for maritime as well as deep sea areas. So all of these are another domains of communication networks. Now, there are equally importantly special applications which are coming in addition to the general communication data requirements that I have already discussed. Let us look at that. For example, one of them is called vehicle communication. So when you cross the international borders so you need some messaging services because towers are not there. If you carry mobile phones, you won't be able to communicate. So how can we create a SATCOM networks in boats that goes for ship fishing or even vessels or in aircrafts? So this is one area where we have put some terminals which is connected to some of the satellites in India. And they can give a huge market because there are not thousands, there are lakhs of such vessels every day going out to the sea, which requires communication infrastructure. Another area of communication is a search and rescue, where people moving around in seas, forest, rescue, disaster occasions where there are no ground infrastructure. How do you really communicate? And what type of satellites can really give such benefits? So for your information, we know that India is a partner in a network called COSPAR SARSAT with 44 members. And since 1991, we have been giving. And last year, we were awarded for one of the best performing partner in this international program for rescue and services, which is a global network. And our ground station operates from Bangalore to support large area, India, and nearby countries as well as Indian Ocean up to Africa. Some area, large area it is covering for use wherever there are such exigencies, our networks come into action. Telemedicine, well known to all of you. How do you really connect to people across non-internet accessible areas through dedicated satellite links so that hospitals can be connected, expert doctors' advice can be achieved. Today, there is a lot of equipments capable of transmitting cardiology, radiology, pathology, and many other oncology consultancies and machines. So the doctors can actually scan and understand all of this and decide on the treatment protocols, not even actually meeting the doctors physically. So this is a great capacity that is provided through internet in bidirectional communication. Similarly, in bidirectional communication is the teleeducation applications where teachers deliver lectures live and students across the country can actually listen to and ask questions and interact. So this is also applicable in some institutions, but then with the advent of internet and many other tools, this prominence has come down in many areas, but there is still rural area which requires and support in teleeducation. But coming days, we will see that this communication is not just limited to communication alone. It will also connect to Earth observation and timing and position network services. So especially with respect to cyber physical systems, robots, sensors, digital control systems, we need to pass on timing information. Timing is so critical for banking. It is critical for railway networks. It also requires for financial networks. So similarly, we need sensors capturing data on real time and use it for computation of many aspects. For example, traffic information and how you can control traffic using such services, centrally controlled networks. Just imagine. So all security, all of this camera networks, across the state, in Kerala itself, there are thousands of video cameras across the road and how they are interfacing and interacting using advanced analytic techniques to make decisions, especially dealing with crime and others. So these type of questions will come and we need to use large-scale infrastructure of communication to support all these activities. Similarly, we need to move to optical communication and as well as quantum key distribution. So optical communication has an advantage that it is beyond the RF range. So it is very secured and it has no limitations of frequency. It can have very high throughput. But then adaptation is a challenge, especially place where rain area, climate, weather, dust, pollution all affect this. So creating large telescopes to have satellite-based communication in optical domain is a new challenge, but work is happening in these areas. Now let me finally look at what is happening in the world. This is what we need, and this is a demand profile as what we look at it. But then globally, there is a lot of things happening in the space communication infrastructure. The global satellite constellations are growing. I think this is very well known to you. I think many of you may be knowing about SpaceX Starlink. They have satellites in the low orbit in the around the 400, below 400 kilometer range, 400, 450. And almost 10,000 satellites are already launched, and this is fully operational. And you know that this is capable of giving internet services through specific terminals which they sell, and you can connect that terminal to your network and then connect it to high broadband connectivity. And this is not just for civilian communication, it is also equally important for strategic communication, defense, and the recent conflict has shown that how SpaceX has been utilized by American government for most of their work. Similarly, another communication network that emerged with a much lesser number of satellites, like around 600, is Eutelsat and OneWeb joint program. Here, there has an Indian component here. The Bharati Airtel is also part of the OneWeb consortia. This is also trying to have a footprint in India in the recent times, but still not got approval. Both SpaceX, Starlink, as well as OneWeb still not got rights to operate from India, though they are saying that it is already given, but I'm not able to see that in operation. Iridium Communication Networks is also a LEO satellite with certain numbers, but still not a very large constellation to compare with any of the SpaceX, which enough power. Similarly, Global Star is also LEO, and there are other MEO, that's medium Earth orbit, as well as geostationary Earth orbit satellite communication networks, which are specifically focused on some domains, not fully a global network. So you can see that the global network is actually expanding. I will talk about the one which is going to come in the coming days. The large constellation under development includes Amazon's. It was called Amazon Kuiper, and they are already working on almost 3,000 satellites to be launched at DO. And deployment already started, launches are already happening. And possibly by 2026 end, they may have their fully commercial operation. This is the only visible challenger to Starlink. And this will slowly enhance their ability to handle the AWS cloud services. Possibly you may are aware of Amazon Web Services, cloud services, which are for consumers, enterprises, and government markets. They offer this. Similarly, China is also working on a Guang constellation planned almost 13,000 satellites, again at LEO, and the initial deployment has started. They wanted to as a rival to Starlink as a global constellation. And there are other constellations under development, for example, Shanghai Spacecom, Qianfan, where they talking about planning 14,000 satellites, again at LEO, and early deployment testing is already going on, which is a mega constellation China, and launches are already getting scheduled. If you look at European Union, other than OneWeb, there is not much work. Of course, there is IRIS cluster, 264 LEO, MEO satellites. There are small ones, for example, Telesat, Lightspeed. Almost 200 advanced LEO satellites are under construction. This will also be operated for users, private and government connectivity. These are American constellation. Blue Origin Satellite Company, which is a launcher company, essentially, they are also trying to launch a constellation called TerraWave with almost 5,400 LEO and MEO constellation announced here. But then construction is not yet started. Possibly they may start around next year. Russian government also announced a sphere called Sephra, again a rival to the American constellation with internet services. They had their first set of launches. But then possibly the scale may not reach this level, but then it's a good thing to see that it is across globe continent it is happening. But the most interesting part out of all of this is the D2D constellation. D2D means device to device. That means you don't need really a ground equipment like an antenna or receiver for talking to the satellite. So your mobile phone will not even understand where the signal is coming, whether it is from the tower or from the satellite. And this is already happening. The satellite company called AST Space Mobile, which is a US company, already launched 5 satellites in space. And one of the satellites was launched by India in the LVM3 recently. And this satellite is like a large antenna, which you see on the picture there. And this satellite will beam the cell-based signal to the ground, and your satellite can directly receive it in the bands that are already built into the satellite. And there is also the plan by Starlink also to direct-to-cell capacity technology is under development. And similarly, the Link Global is also trying to develop D2D constellations. And once day-to-day constellations come, I think many of the services of the mobile services will switch, and this will actually disrupt the entire terrestrial infrastructure called the towers. And you may not require towers any longer, except when, until then the capacity in the satellite reaches a threshold to handle the demand for communication at that point in time. But this is a very interesting development. And once it happens, you will be able to use mobile phones and flights, ships, and wherever you go in forest, without even bothering about wherever you are, whether you have a tower covering it or not. And these questions will vanish, and that's going to be one of the interesting things that you will watch. Now, let me look at what India will do in the coming days. So if you really see, the constellations would expand in the coming days to almost 40,000 to 60,000 communication satellites in the orbit in the next decade, which is good. But then space is going to be cluttered with a large number of satellites, and you'll find it more and more difficult to get orbital slots, coordinate frequencies, avoid interferences, etc. And this also creates military activities becoming more and more dependent on the satellites, and remote regions will no longer be remote. So it means working across the globe will be very, very easy. But India's answer to this is still not visible. If you look at India, like China or even Russia or Europe, you don't have a sovereign satellite constellation to handle this threat. What is the threat? The threat, you understand that when, suppose you, this Starlink or OneWeb or many of them start operating in India, you will see that they will decide what type of communication infrastructure that you need. And they can switch it off at any point in time, and that will be a serious issue. And that cannot be the one which is required for our nation. For example, in the time of a conflict, we need a strategic asset that will handle the threat. And it's also a big market. We still have a very large percentage of penetration in the rural area, not reached by internet. So what are the answers that we can give? Whether ISRO and NSIL can actually solve this problem by giving more satellites, or people like Geo, Reliance, who have a large terrestrial network, can get into space, or any other operators are available. And I want to tell you that happy news that we are seeing light of this. Some of these answers will be yes, and I'm very sure about it. Recently, some announcement has come, and which gives a very interesting aspect of India's emerging satellite constellation networks. Another interesting part is the launchers. If you have to launch thousands of satellites, you need that type of launchers. In India, there are no large-scale launching capacity in terms of numbers. So there are SpaceX launches every week, and we launches occasionally. So that creates problems. So how do we really enhance launching capacity? So we see from startup companies, the rocket building is actually happening. And this, in another 2 years of time, I believe this type of capacity will come in India, and we will be in a position to do this. So I have a great hope that our digital infrastructure, public digital infrastructure capacity, the demand for a lot of data, our ability to work on software and AI, and seamless connectivity across the country will really drive a huge business in India. And once you build it, it will also be helpful for a global connectivity for all of us across the nation, so that our movies can be seen across the world and people will get connected much seamlessly. So with that, let me conclude and say thank you to all of you. And this space domain in communication and infrastructure and networks, very, very exciting. But I didn't go too deeper into the technical aspect of which is another topic possibly will be discussed in the due course. Thank you so much, and wish you all the very best.
Thank you, Somana sir, for your keynote address and the faculty members, students, and other participants. So I think one question to you, it's a really successful, amazing journey. Started with a mechanical engineering student of TKM Engineering College, and now you are into this space. And as a students, to the message to students, as well as to faculty members, how the interdisciplinary aspects will work out. Now you are seeing everything, not mechanical, electronics, communication, even chemical. So all these aspects of engineering, civil engineering, structural engineering. So a man who started as a simple mechanical engineer, and now you are into this space and advisor all your positions. So a message to the engineering fraternity, how the engineering should be looked as an interdisciplinary. And again, starting from campus, What are the projects to be undertaken as a simple step forward to start with? Over to you, sir.
Thank you. I think you raised a very pertinent question here. One, of course, you have to take some branches. Unfortunately, our curriculum is such that you need to select some branches to study something. You become mechanical engineer, chemical engineer, electronics engineer at the end of it. But only thing I want to make you understand, this graduation is only a certificate that you are in a position to learn things, not that you have become an engineer at all. I can guarantee you that, because colleges cannot actually make you a full-fledged engineer. You go through life, you go through work, you go through experience, and you really become an engineer. Unfortunately, like medical professionals, we do not have internships and a post graduation. They go through 1 year hospital services in doctors, No, engineers don't actually go through. You go straight from college to work, sport, or higher studies. See, there is a gap happening. The gap is that what industry needs are not really understood by colleges or even students who graduate. Industries require multidimensional people. They are not expecting people with mechanical engineering, electronics engineering, or chemical engineering. They want people who will solve problems. Problem solving requires ability to understand other domains. That's why, for my case, though I joined as a mechanical engineer, I soon realized I need to understand many more things. I have to do a lot of programming. I need to know a lot of CAD. I need to do a lot of analysis. I need to understand chemical engineering, adhesives, propellants, and soon understood that I need to get into domains which were not familiar to me. And I soon decided to learn all of them. So talk to people, understand, read, and upskill yourself. So it has to continuously happen. But you also have to become deeper in some domains. Sometimes some people are not multidisciplinary. They have become deeper. I think this is also okay. Some people will continue to remain in research mode. But even to do research today, if you do not understand electronics and software, there is no mechanical engineering today. Because if you have to have sensors and robotics, they are sensors, and you need to understand how sensors function, how software is used to capture data, analog data to digital, how digital data conversion takes place to drive a controller. If you do not understand, you cannot build a robot. So the communication infrastructure is so important. Without communication, nothing can be really done. Measurements become itself is a complex topic which requires so much understanding beyond the mechanical engineering. You also talked about civil engineering and structural engineering. I know that structural engineering become integral part of mechanical engineering, though it was little bit taught. But realize that if you have to design rockets, you need to have a great depth of understanding of structural mechanics, dynamics, control, interaction. I think all of this I learned after some time, and in my specialization was in that specific topic later, both in my aerospace mechanic, MTech, as well as in PhD. So they are actually done by civil engineers. But then if you do not understand that, you cannot actually design a rocket at all. So why essentially tell you is people is that keep your eyes open. Understand that you need to become a engineer, total engineer. Then you need to understand, at least respect other domains. You must create an interest in other domains. At least you start reading them. You cannot become an expert in every domain. It is impossible. Become an expert in one domain very deeply, but also become capable of understanding other domains, so that when you work with other people from other domains, you will be able to appreciate, understand how the interplay happens. And that is what is very crucial to doing things, problem solving, etc. And that has been my journey. That's why I'm able to understand domains which are not at all connected with that. And even not just understand, I will be able to figure out, even find problem solving in those domains, though I may not be an expert. I think the common sense understanding is very, very important. I think that once you understand the mathematical principles across domains are one and the same. One more thing I want to tell you, that new technologies are emerging that is changing everything. For example, chemistry we used to learn is now computational. Physics was always mathematical, but chemistry we never imagined that will become computational. And biology is also becoming computational. I think it's too much mathematics goes into biology today, and modeling, simulation, all of that goes into those domains. So the boundaries are falling between domains. I think even in colleges, I think departments should not be created today. I think we have to look at problem, and that problem solving multidisciplinary professors should come together to solve. So earlier, like physics, chemistry, mathematics, engineering, these branches all have to vanish soon. I think that is a time that is coming. And I hope that students understand this and prepare for advancing their career and future by embracing other domains, which is not their core. I think that's very important.
I hope that your vision will be implemented in across all universities and institutions in India. And thank you, sir, for giving such an elaborative note. And now I request the participant to unmute yourself and maybe ask questions. Maybe we'll take 2 or 3 questions considering your time frame also. We do understand.
Sir, myself, Dr. Prajun, Jyoti Engineering College only. Thank you for your insightful session. My question is, gallium nitride technology is considered crucial for next generation communication, space and defense system. How far India has progressed in gallium nitride technology, and what are the key challenges in achieving global competitiveness?
So if you look at the GaN technology, primarily in India, the work is happening only in sensors, not much into full-fledged devices. So if you look at some of the small foundries which are available and the research happening in GaN and GaAs, you see this problem. But especially this area is crucial for the new communication systems, power devices, and especially the new frequencies which are emerging. This becomes important. But much of the work is not happening in India. Hopefully, this discussion. In fact, I was part of another discussion yesterday also in Delhi. How to really create compound semiconductor fabs, reasonable scale, and we found that could be much cheaper to build it compared to the silicon fabs. But then it has to be done. I think the investment is still not there visible, though there is some small fabs which are doing teaching, upskilling people there happening. So if India has to really make a jump start, it may not be in silicon. It could be in compound semiconductors. That is all of us understand that way. So I can only answer this much today. There is so much of a journey required. I think the development of this semiconductor infrastructure is not linked to knowledge alone. It is linked to many other things, including geopolitics and investments. So government understand this, and I think they will slowly push for such ideas. Thank you.
Sir, we'll take one more question.
Sir, myself Chippy, faculty of Jyoti Engineering College. We know we have many satellites for our communication support, but we are in a West Asia conflict now, and Iran threatens to target some submarine cables that we deeply depend on international internet and data traffic. How it will affect India, and how can we manage that if it happens?
If submarine cables are affected, we will definitely have impact, because the high throughput that is provided through submarine cable cannot be provided by satellites at all, because there are no satellite networks that are having that type of data capacity. Possibly you can handle emergency communication to satellite bandwidth, whereas the optical cable band capacity is enormous to handle large traffic which is happening. So the only option today is to protect it. I think protection will happen through other channels, and of course there are redundant channels and other networks. They are not star topology. They have a topology which is resilient to one cut, etc. But then still, it will create some disruption for some time. But then once you have a global internet service-based networks as a constellation, it can handle reasonably well. For example, a Starlink network can handle an American government communication across the globe even without fiber. So that is definitely there. But for India to reach that level, I think it will take time. As I discussed, somebody has to build a large constellation of networks, satellites. Then such eventuality of the fiber getting fully damaged can be handled. Until then, it is a serious issue.
Thank you, sir. Can we take one more question from the audience?
Yeah, please.
Any participant, please unmute and ask your questions. Any questions? So as such, we don't see any questions. Now I request Dr. Jose P. Theratil, Head of Electronics, for the word of thanks. Over to Dr. Jose P. Theratil, sir.
Yes, sir. Thank you, sir. Respected Father Dr. Jose Kannambura, our academic director, Dr. P. Sojanlal, principal, dear faculty colleagues and participants, a very warm good morning to all. Above all, we owe our deepest sense of gratitude and reverence to our most distinguished chief guest and resource person, Dr. S. Somanath, former Secretary, Department of Space and Chairman, ISRO. Sir, despite your extraordinary stature and demanding responsibilities at the highest levels of India's space program, you graciously joined us today and delivered an address that was nothing short of inspirational. Your vision of next generation communication systems and the future of space technology has truly elevated the spirit of this faculty development program. We are deeply honored by your presence and immensely privileged to have you as our resource person for the very first technical session. We also extend our sincere thanks to Reverend Father Dr. Jose Kannambura for his warm and encouraging welcome address, and Dr. P. Sojanlal for his motivating presidential address. Our gratitude goes to all participants, online and offline, and to the organizing team for their dedicated efforts. We look forward to enriching program ahead. Thank you all. Thank you.
Thank you, sir, for joining. And
Thank you.
it's time, sir. And because of your busy schedule, we know that we are going to close this session. And once again, thank you, sir. Warm wishes, best wishes from Jyoti Engineering College, all the participants and everyone. And for the participants, we'll log in back at 1 o'clock. Okay. Thank you, sir. Thank you, bye-bye.
Thank you. Thank you so much.
Thank you, sir.